The universe is not real. Let's first explore what we mean by reality. Our everyday experience leads us to believe that the world around us is solid, tangible, and separate from our thoughts. However, the nature of reality has been a subject of contemplation for both philosophers and scientists throughout history. To better understand reality, we can turn to scientific theories such as quantum mechanics. At the microscopic level, quantum mechanics describes the behavior of particles and energy. It introduces us to a world that defies our classical intuitions. According to this theory, particles can exist in multiple states simultaneously until they are observed, at which point they collapse into a single state. This peculiar phenomenon, known as the observer effect, challenges our understanding of an objective reality. It suggests that our observation or measurement has a direct influence on the state of particles, blurring the line between the observer and the observed. In essence, the act of observation participates in the creation of reality. Moreover, the field of neuroscience explores how our brains construct our perception of reality. Our senses gather information from the external world, which is then processed and interpreted by our brains. However, this process is not infallible. Our brains can be deceived, leading to perceptual illusions or hallucinations. This demonstrates that our perception is not an accurate reflection of an external, independent reality. When we delve into philosophy, we encounter various perspectives on reality. Idealism, for example, posits that reality is fundamentally mental or consciousness-based. It suggests that the universe and everything within it are constructs of our minds. This viewpoint challenges the notion of an objective reality existing independently of our thoughts. Another intriguing concept is solipsism, which suggests that only one's mind is certain to exist, and everything else is uncertain. It questions the existence of an external reality altogether, proposing that everything we perceive is a creation of our individual consciousness. Our perception is a key factor in how we make sense of the world around us. However, it's important to recognize that our senses can sometimes deceive us. Let's explore this idea further by examining optical illusions, hallucinations, and dreams, which demonstrate that our perception isn't always a reliable representation of the external world. This raises an intriguing question. If our senses can be tricked, can we truly trust our perception? Optical illusions are fascinating examples of how our brain can misinterpret visual information. These illusions occur when our brain processes visual stimuli in a way that differs from reality. One well-known example is the Muller-Lyer illusion, where two lines of the same length appear to be of different lengths due to the presence of arrows at their endpoints. This illusion shows that our perception of length is influenced by contextual cues and can be manipulated. Hallucinations are another phenomenon that challenges the reliability of our perception. They occur when we perceive something that isn't actually present in the external world. Hallucinations can be induced by various factors, such as certain drugs, mental health conditions like schizophrenia, or even extreme fatigue. These experiences demonstrate that our perception can be altered, leading us to question the accuracy of our sensory input. Dreams offer yet another perspective on perception and its fallibility. During dreams, we often experience vivid and immersive scenarios that feel real. While dreaming, our brains create entire worlds and events that exist solely within our minds. This shows that our perception of reality can be constructed internally, independent of external stimuli. From a technical standpoint, our perception is an intricate process involving our sensory organs and the brain. When we receive sensory input, such as visual or auditory information, it undergoes complex processing in specialized areas of the brain. However, this processing is not infallible, as it can be influenced by factors like attention, memory, and prior experiences. Furthermore, our perception is subjective, as it is shaped by individual differences, biases, and cultural influences. What we perceive may differ from person to person, highlighting the subjective nature of reality as we experience it. Renowned philosopher René Descartes famously stated, "I think, therefore I am." However, what if the physical world we perceive is nothing more than an illusion constructed by our thoughts? Some philosophical and metaphysical theories propose exactly that, suggesting that the universe, including everything we perceive, is a product of our consciousness. This perspective challenges the concept of an objective reality. One philosophical viewpoint that explores the idea of the physical world being an illusion is known as idealism. Idealism suggests that reality is fundamentally mental or consciousness-based. According to this perspective, everything we perceive as physical objects or events are constructs of our minds. In other words, the external world is a projection of our consciousness. From a technical standpoint, this philosophical stance questions the nature of perception and the relationship between our mind and the physical world. It challenges the assumption that the external world exists independently of our thoughts and observations. Advancements in neuroscience have shed light on how our brains construct our experience of reality. Our perception is not a passive reflection of the external world, but rather an active process of interpreting sensory information. The brain receives signals from our senses and processes them, constructing our perception of the world. This suggests that our conscious experience is a product of neural processes within our brains. Furthermore, cognitive science explores the role of our beliefs, expectations, and prior experiences in shaping our perception. Our brains continuously make predictions about the world based on past information, and these predictions can influence how we perceive and interpret sensory input. This dynamic interplay between our mind, beliefs, and sensory input adds another layer to the argument that the physical world may be an illusion. In quantum physics, there is an intriguing concept called wave-particle duality. It suggests that particles, such as electrons or photons, can exhibit both wave-like and particle-like properties depending on how they are observed or measured. This implies that the nature of reality at the quantum level is dependent on the act of observation, blurring the line between the observer and the observed. It raises questions about the role of consciousness in shaping the physical world. While these ideas challenge the notion of an objective reality, it's important to note that they are philosophical and metaphysical in nature. They invite us to question our assumptions and explore different perspectives on the nature of reality. The debate between objective reality and subjective perception continues to fuel philosophical discussions, reminding us of the profound mysteries that surround our existence. The concept of simulation theory, a hypothesis that has captured the imaginations of many in recent years. According to this idea, our entire reality could be comparable to a highly advanced computer simulation, similar to a video game. If simulation theory were true, it would mean that the universe we experience is merely a simulated construct, fundamentally unreal as we commonly perceive it. The basic premise of simulation theory is that a highly advanced civilization, far beyond our current technological capabilities, has created a simulated reality that we unknowingly inhabit. This simulation could be the result of incredibly powerful computers running complex algorithms, generating our perceived universe with its physical laws, space, time, and even the conscious beings within it. To understand the plausibility of simulation theory, we can draw parallels to our own technological advancements. Consider the evolution of video games. From the early days of simple pixelated graphics to today's hyper-realistic simulations, our progress in creating immersive digital worlds has been remarkable. If our own civilization continues to advance technologically, it is conceivable that we might one day develop simulations that are indistinguishable from reality. When examining simulation theory from a technical perspective, we can consider the concept of computational power. In order to simulate an entire universe with sentient beings, one would require an immense amount of computational resources. The simulation would need to process and render every detail, from subatomic particles to galaxies, and simulate the thoughts and experiences of conscious beings within it. Another aspect to contemplate is the presence of glitches or anomalies in our perceived reality. Just as video games sometimes have bugs or inconsistencies, proponents of simulation theory suggest that certain unexplained phenomena, such as déjà vu, paranormal experiences, or unusual coincidences could be indicative of glitches in the simulation. Simulation theory also intersects with concepts from quantum physics. Quantum mechanics reveals a fundamental level of reality where particles exist in superposition, multiple states simultaneously, until observed or measured, at which point they collapse into a single state. This behavior aligns with the computational nature of a simulation, where calculations are performed only when needed to generate the perceived reality. However, it's important to note that simulation theory remains speculative and is currently unverifiable. Proving or disproving the hypothesis is challenging since, as simulated beings, we lack the means to access or examine the external reality beyond our simulated world. Quantum mechanics, where the nature of reality takes on an extraordinary twist. One of the fascinating phenomena within this field is the observer effect, which challenges our intuitive understanding of how the world works. According to this principle, particles in the quantum realm can exist in multiple states simultaneously until they are observed, at which point they collapse into a single state. This raises profound questions about the role of consciousness in shaping reality. Let's dive into this perplexing concept, striking a balance between simplicity and technical details. Quantum mechanics is a branch of physics that describes the behavior of particles and energy at the smallest scales, such as atoms and subatomic particles. It revolutionized our understanding of the fundamental building blocks of the universe and introduced us to a realm that defies our classical intuitions. At the heart of quantum mechanics lies the principle of superposition. This principle states that a quantum system can exist in multiple states simultaneously, akin to being in multiple places or having multiple properties at once. For example, a particle can be in a state of both up and down spin until it is observed. However, when a measurement or observation is made on a quantum system, something remarkable happens. The system collapses into a single state, and the observed properties become definite. This collapse is known as the observer effect, and it is a fundamental feature of quantum mechanics. The observer effect implies that the act of observation itself influences the state of the quantum system. Prior to observation, the system exists in a superposition of possible states, but when an observer interacts with it, the superposition collapses into a single, well-defined state. The observer effectively becomes an integral part of the system, shaping its outcome. The implications of the observer effect raise profound questions about the role of consciousness in shaping reality. It suggests that our observations or measurements actively participate in the creation of the reality we perceive. The consciousness of the observer becomes intertwined with the behavior and properties of the quantum system being observed. However, it's important to note that the observer effect does not necessarily require a conscious human observer. Any interaction that causes the collapse of the quantum system, such as a measurement device or an automated experiment, can produce the effect. The key factor is the act of observation, which brings the superposition to a definite state. The observer effect has been extensively tested and verified through experiments in laboratories. These experiments have shown that the behavior of quantum systems changes depending on whether they are observed or left unobserved, reinforcing the fundamental role of observation in quantum mechanics. In traditions like Advaita Vedanta, Zen Buddhism, and Taoism, the notion of non-duality challenges the idea of a separation between the self and the external world. According to these philosophies, reality is seen as a unified whole, devoid of distinct entities. Within this perspective, the notion that the universe is not real becomes an exploration of the ultimate truth. In Advaita Vedanta, a school of Hindu philosophy, non-duality is known as Advaita, which means not two or non-dual. It posits that there is an underlying unity that transcends the apparent diversity of the world. According to this philosophy, the individual self, or ego, is an illusion that gives rise to a sense of separation from the external world. The ultimate truth is seen as the realization that the self and the universe are fundamentally one and the same. Zen Buddhism, originating from the teachings of the Buddha, emphasizes direct experience and meditation. In Zen, non-duality is expressed through the concept of emptiness or interdependence. It suggests that all phenomena are interconnected and lack inherent, independent existence. The separation between self and the external world is considered illusory, and the practice of meditation aims to awaken to the non-dual nature of reality. Taoism, a Chinese philosophy rooted in the Tao Te Ching, also embraces non-duality. The Tao, often translated as the Way, represents the underlying principle of the universe. Within Taoism, the concept of Wu Wei, or non-action, encourages living in harmony with the natural flow of the Tao. This involves transcending the illusion of separation between the self and the external world, recognizing their intrinsic unity. From a technical perspective, non-duality challenges our ordinary dualistic thinking, which categorizes the world into separate entities and concepts. Instead, it points to the interconnectedness and interdependence of all phenomena. It suggests that our perception of distinct entities, such as self and world, is a a result of conceptual frameworks and conditioning, rather than an accurate reflection of reality. In non-dualistic philosophies, reality is often described as ineffable or beyond conceptual understanding. It is not something that can be grasped through intellectual analysis alone, but rather something to be directly experienced or realized through contemplative practices such as meditation or self-inquiry. Non-duality invites us to question the boundaries we perceive between ourselves and the external world. It challenges the notion of a separate, independent self and encourages a shift in awareness towards a holistic understanding of existence. Get ready to explore the mind-boggling phenomenon of quantum entanglement, where particles become intrinsically linked in such a way that their states become instantaneously correlated, regardless of the distance between them. This mysterious interconnectedness hints at a deeper underlying fabric of reality, suggesting that everything is fundamentally entangled and interconnected, challenging the notion of discrete existence. Quantum entanglement is a peculiar feature of quantum mechanics that occurs when two or more particles become correlated in a way that their properties, such as position, momentum, or spin, become intertwined. These particles are said to be entangled with each other. To understand the implications of quantum entanglement, let's consider an example with two entangled particles, often referred to as entangled pairs. When the properties of one particle in the entangled pair are measured, such as its spin, the measurement instantaneously affects the other particle's spin, regardless of the distance separating them. This correlation holds true even if the two particles are light years apart. The concept of entanglement challenges our classical intuitions because it suggests that the entangled particles are not separate entities with well-defined properties until they are measured. Instead, they exist in a superposition of states, where their properties are undetermined until the moment of measurement. Once one particle's state is observed, the other particle's state is immediately determined, creating an instantaneous correlation between them. From a technical standpoint, quantum entanglement arises from the nature of quantum superposition. In the quantum realm, particles can exist in multiple states simultaneously, thanks to the principle of superposition. When two or more particles interact in a way that their quantum states become entangled, their combined state becomes a complex, entangled superposition. The phenomenon of entanglement has been extensively studied and verified through numerous experiments. Notable experiments, such as the Bell tests, have confirmed that the correlations between entangled particles cannot be explained by classical physics. The results support the idea that entanglement is an inherent feature of quantum mechanics, defying our classical understanding of causality and locality. The interconnectedness implied by quantum entanglement challenges the notion of discrete existence. It suggests that the boundaries between particles and systems are not as clear-cut as they may seem. Instead, there is a deeper, underlying interconnectedness that transcends spatial and temporal separations. Scientists and philosophers have explored the implications of quantum entanglement, often invoking the idea of a unified and interconnected reality. It raises intriguing questions about the fundamental nature of reality and the relationship between the observer and the observed. While quantum entanglement is a well-established phenomenon in the realm of quantum mechanics, its implications for macroscopic objects or everyday life remain an area of ongoing research and speculation. Nonetheless, the existence of entanglement highlights the profound interconnectedness that underlies the fabric of reality, challenging our conventional understanding of separation and individuality. Throughout human history, philosophers, scientists, and thinkers have grappled with the fundamental question: why does anything exist at all? This question takes us to the very heart of our existence and challenges us to explore the nature of reality. Existence, in its most basic sense, refers to the state of being or the fact of existing. It encompasses everything that is, from the vast expanse of the cosmos to the tiniest particles that make up our world. Yet, the question of why anything exists remains elusive, transcending the boundaries of our current understanding. In the realm of philosophy, the question of existence has been contemplated through various perspectives. Some philosophical traditions propose that existence is a necessary aspect of reality, a fundamental principle that cannot be further explained. In this view, existence is an inherent property of being itself, without the need for an external cause or explanation. On the other hand, scientific inquiries seek to understand the mechanisms and processes through which existence manifests. Fields such as cosmology, particle physics, and biology explore the origins and evolution of the universe and life, shedding light on the intricate workings of existence. In the realm of cosmology, the study of the universe, scientists seek to uncover the origins of the cosmos. The prevailing scientific theory, known as the Big Bang Theory, suggests that the universe originated from an incredibly dense and hot state, expanding and evolving over billions of years into the vast cosmos we observe today. However, the question of what triggered the Big Bang and why the universe exists in the first place remains unanswered. In particle physics, scientists investigate the fundamental constituents of matter and the forces that govern their interactions. The Standard Model, a foundational theory in particle physics, describes a complex framework of elementary particles and their interactions through fundamental forces. While this model has been tremendously successful in explaining and predicting the behavior of particles, it does not directly address the question of why these particles exist or why there is something rather than nothing. In the field of biology, scientists study the intricate processes that give rise to life. From the formation of complex molecules to the evolution of organisms, biology explores the mechanisms through which life emerges and thrives. However, the question of why life exists in the universe and why it exhibits such remarkable diversity and complexity remains a subject of ongoing scientific investigation and philosophical contemplation. The mystery of existence challenges the limits of our current understanding. It prompts us to ponder the nature of reality, the origins of the cosmos, and the fundamental principles that govern our existence. While science provides us with valuable insights and theories, it also recognizes that there are still gaps in our knowledge, and certain questions may be beyond the scope of our current methodologies. In contemplating the mystery of existence, we are invited to embrace a sense of wonder and awe. It reminds us of the vastness and complexity of the universe, humbling us in the face of the unknown. The quest to unravel the mystery of existence continues to inspire scientific inquiry, philosophical speculation, and a deep exploration of our own place in the cosmos. Thank you for joining me on this thought-provoking exploration. If you enjoyed this video, be sure to like, share, and subscribe for more mind-expanding content. And remember, the quest for knowledge and understanding is an endless adventure. Until next time, keep questioning, keep seeking, and keep exploring the limitless possibilities of our mysterious universe.